Hi everyone. Today you'll be taking scientific notation notes. And scientific notation is a shorthand way basically to represent really big numbers and really small numbers. Here's a really big example, 154 billion. This first factor right here is always going to be less than 10 and greater than or equal to 1. So the number has to be between, the first factor, has to be between 1 and 10. The second factor, the base, is always going to be 10, and your exponent is going to tell you how many spaces to move your decimal. If it's a positive exponent, like this 11, we're going to move our decimal to the right because it's a really big number. And if it's a negative exponent, we're going to move our decimal the other direction to the left to show that it's a really small exponent. So we're going to review very briefly on the next part of your notes. Remember that a number written correctly into scientific notation must have a number that is less than 10 and greater than or equal to 1. So between 1 and 10. Then you multiply by a base of 10, and your exponent tells you how many times to move your decimal point. So looking at these examples, 73 and 2/10 times 10 to the negative 2 power is not written properly because 73 and 2/10 is not between 1 and 10. It is definitely greater than 10. 5 and 8/10 times 10 to the third power. Now this example is written correctly. 5 and 8/10 is definitely between 1 and 10. We have a base of 10 here, and we have the exponent of 3. So that is a good example. 25 hundredths times 10 to the ninth power. 25 hundredths, that first example, is not between the whole numbers 1 and 10. Therefore, that first factor does not make it a good example. And lastly, 2 and 3/10 times 10 to the 2 and a half or 2 and 5/10 power. Well, the 2 and 3/10 is actually a good factor. It is between 1 and 10, but we don't want an exponent 2 and 5/10 as our part of our scientific notation. So no, that is not a good example. So moving on, looking at your examples here, 8,900 hundredths or 8,900. If the decimal, and it always is in the back, you don't see it right now, but we need to move. So our first factor is going to be between 1 and 10. So we need to move that decimal from the 0 to between the 8 and the 9. And we're going to do that 1, 2, 3 times. And that's why we write our first factor as 8 and 9/10 times 10 to the positive 3 power, because we know that's a really big number. Looking at 7,800,000, and I'm going to write a little larger. 800,000, excuse me. It's a whole number, so the decimal is back here. We want to move it between the 7 and the 8. So our first factor is going to be 7 and 8/10. And we're going to move that decimal 1, 2, 3, 4, 5, 6 places. So it goes between that 7 and 8/10, excuse me. And then we're going to put our second factor, base 10. How many times did we move that decimal? We moved it 6. Why is it a positive exponent? Well, because that's a really big number. All right, 20,000. Where's the decimal right now? It's in the back. We want to move it to behind the 2 or between the 2 and the 0. So we can write 2. You don't need to put that decimal there because there's nothing after it. Times 10 to the, how many places did we move? 1, 2, 3, fourth power. So 2 times 10 to the fourth power. Why is it positive? Because it's a really big number. Please click on the next slide to see the very last part of your notes.